Hello there, and welcome. Tonight, we're setting course for the impossible, a sprawling spiral of stars that cradles us in its arms, yet remains mostly invisible to our eyes. The Milky Way isn't just our galaxy. It's a machine older than Earth, built from shattered worlds and ancient light. Some of its stars were born before the galaxy itself. Others are being flung into the void as you listen. It breathes, it grows, it remembers, and it's stranger than anything science fiction ever imagined. So if your mind is curious but your body is tired, you're in the right place. There's nothing you need to do now. Just rest and listen. And while you're settling in, before your eyes grow too heavy, I'd love it if you gently tapped subscribe or press the little hype button YouTube recently added. It's a small click, but it helps keep these experiments and explorations orbiting out into the algorithm. You can also leave a comment telling me where you're listening from and what time it is in your corner of the night. It's oddly fascinating to see where people are drifting off with us, scattered across the world like stars across the galaxy. Now take a deep breath, let your day drift away, and let's travel together into the quiet corners of the universe. From where you're sitting right now, maybe on a bed or a couch or a floor with a quiet lamp and a tired body, you can't see it, but it's there, spreading out in all directions, stretching across space like a vast luminous tide, is the Milky Way Galaxy. Not the streak across the sky you may have seen on a clear night, not the painted band of stars that camera lenses can capture in long exposures. That's just the faint whisper of the thing, a sliver. The real Milky Way, the one you live inside, is hundreds of billions of stars, stitched together with dark matter and cold gas and invisible motion. It's not overhead, it's not out there. You're already inside it. And that's the first trick. We tend to picture the Milky Way like an object in the sky, something you look up at. But it's more like the ocean when you're floating in it. There is no out there. You're part of it. You're bobbing quietly in the spiral arm of a galaxy so large that light takes over 100,000 years just to cross it. If you started driving in one direction at highway speed, it would take you longer than Earth's entire history to reach the other side. And the whole time, you'd still be inside. From our position near the inner edge of a small spur called Orion, we can't see the whole galaxy. We don't get the luxury of looking at it from above. It's like trying to draw a map of a forest while standing inside a single tree. You can measure the bark, watch the shadows, feel the wind, but the shape, the full, spiraled form, that part has to be imagined, deduced, reconstructed from fragments. That's how we learned about the Milky Way, not from direct sight, but from patterns, from the motion of stars, from the flickering of hydrogen clouds, and the way light bends and reddens as it passes through interstellar dust. The Milky Way doesn't show itself easily. You have to ask the right questions. And even when we do see it, when you finally find a place dark enough, far from streetlights and cities and blue phone screens, what you're seeing is still only the barest hint. You might count a few thousand stars on a good night, but the galaxy holds at least 100 billion. Some estimates say closer to 400 billion, and that's not counting the planets, or the rogue stars drifting alone, or the black holes spiraling in silence. Most of it is hidden. Dust veils the core, distance dims the edges. We look up and think we see the cosmos, but really, we're looking through a narrow window smeared with fog, and on the other side is something so immense, so crowded and wild and ancient, we still don't fully understand its shape. It's not flat either. Not really. The Milky Way's disk is warped, bent like a spinning vinyl record left too long in the sun. Some parts rise, others droop. And the core, the galactic heart, isn't a neat glowing ball. It's a twisting, elongated bulge, shaped like a peanut or an hourglass. Inside it lies a supermassive black hole, quiet for now, but pulsing gently as stars whirl around it. All of this This rippled disk and crowded center and ghostly halo of dark matter rotates slowly through space, turning on an axis we cannot see. It drifts through the universe like a living thing. But from here, it's a strip, a smear of stars across the sky. From here, it's a backdrop. And maybe that's the strangest illusion of all, that the Milky Way is passive, that it just sits there while we build cities and launch rockets and wonder what's beyond it. The truth is, it's not still. It never has been. Every star you can see is in motion. A cloud of gas is shifting. The whole structure is a pattern of movement held together by gravity and inertia and time. Even your own solar system, the ground beneath your feet, is orbiting the galactic center at over 800,000 kilometers per hour. That's more than 230 kilometers every second. But the distances are so vast and the scale so unimaginable that it feels like we're frozen in place. In the time it takes for the solar system to make one full orbit of the galaxy, a galactic year, entire epochs pass on Earth. 225 million years. Dinosaurs rose, ruled, and vanished in one galactic year. Continents drifted, oceans opened, life emerged from the sea, all while the sun, quiet and constant, traced a looping path through the spiral arm of this enormous system. But we don't feel it. We don't hear it. The galaxy moves in silence, and because it doesn't rush, because it doesn't flash or roar or spin in days, we mistake it for stillness, for background. So, we imagine we live in a solar system, surrounded by stars, but we don't. We live in a galaxy, and the solar system is just our address within it. One speck among billions, orbiting an average star that floats along with others in a slow, glowing swirl. And even that swirl is incomplete. Some stars orbit in the opposite direction. Some dive up and down through the disk like dancers in tilted ellipses. Others move so fast they'll eventually leave the galaxy altogether, flung out by ancient collisions or the violent tug of the black hole's gravity. It's not a clock. It's not a wheel. It's more like a current, layered, shifting, irregular. There's form, but not perfection. There's symmetry, but only loosely. The Milky Way is not neat. It's wild, it's evolving, and it's far from done. What we see from Earth is the thinnest thread of the whole, a stitched line of stars and stories stretching across the night. But beyond that line, above it, behind it, around it, lie hundreds of billions more. Stars with planets, planets with moons, moons with ice and heat, and possibly even life. We don't know yet. We're still learning how to see. We are part of this galaxy, made from its material, moving with its motion. The atoms in your body were forged in stars that lived and died in its spiral arms. You are not on the edge of the Milky Way. You are inside it, living in a moment between supernovae, floating in a neighborhood that has changed 1,000 times before and will change again. This is not just the backdrop of your life, it's your home. If you step outside on a quiet night and look up, you might feel like everything is still. The stars don't rush past. The moon hangs patiently. Even the wind, even the trees, even your own heartbeat might feel more urgent than anything happening above you. It's easy to believe we're standing still, that Earth is a kind of fixed place, solid and rooted in the sky. But that calm you feel is a kind of illusion. Because right now, even as you breathe, you are moving through space at over 828,000 kilometers per hour. The entire solar system, our sun, our planets, our comets and dust and rings, is on a grand orbit around the center of the Milky Way. A path so vast, it takes over 225 million years to complete. That's not a journey we'll ever feel. Not in the way we feel a car accelerate or an airplane lift off. But we are on it, and we always have been. Every one of your ancestors, every breath of history, every ice age and extinction, every fire lit by human hands, it all happened while Earth was sweeping along this slow spiral path, thousands of light years wide. We call it a galactic year, one complete loop around the galaxy. It's an orbit defined not in months or seasons, but in epochs. When Earth last completed a galactic year, the continents were joined together in a massive supercontinent called Pangaea. Dinosaurs hadn't evolved. Mammals didn't exist. Trees were different. The air was different. The sky was full of unfamiliar stars. Earth was in a completely different part of the galaxy, and we've only gone around about 20 times since the solar system formed. If that sounds slow, it's not. It's incredibly fast. But speed, in cosmic terms, is deceptive. That's because the distances involved are so vast, they swallow our intuition. You are moving 230 kilometers every single second. That's the distance of a long highway drive, every heartbeat. But there are no signs, no wind in your face, no stars streaking by to remind you. Space doesn't offer resistance, and nothing out there makes a sound. And so, from here, it feels like nothing's happening at all. It's strange to think that you are part of this motion, that as you sleep or sit or walk through your day, the ground beneath you is spinning on Earth's axis, and Earth itself is orbiting the Sun, and the Sun is orbiting the center of the galaxy, all at once. Layer upon layer of movement. Yet we feel grounded, rooted. That feeling isn't wrong, but it's not the whole story either. The galaxy doesn't rush. It turns in slow spirals, bound by gravity and sculpted by time. And we, caught in one of its arms, are along for the ride. Our position is just one thread in a woven pattern of stars and dust, all moving together. But the pattern is not fixed. Over time, we drift. We rise and fall through the galactic plane like a cork on waves, moving in gentle oscillations that take millions of years to complete. Some scientists wonder if this motion, this slow bobbing through the galaxy's density, might be linked to mass extinctions on Earth. It's possible. Every loop around the Milky Way brings us through new regions of space. Some calm, some turbulent, some filled with debris or radiation or distant gravitational threats. The journey is not just circular. It's a path with texture and depth, yet the silence of it is disarming. You would never guess the velocity. You would never know that the Sun itself is carving a great arc through space, dragging its planets behind like a ribbon, each one orbiting in ellipses that tilt and shift and precess. And all of it, this celestial machinery, moves within a galaxy that itself is in motion, rushing through the universe toward an unseen future. We live in the middle of that, not in a perfect spiral, but in a rough, rippling sea of stars that stretches farther than we can measure. The stars you see at night are not fixed. They are drifting, some slowly, some quickly. And over time, the constellations we name and memorize will come undone, like sand patterns in wind. The Big Dipper will change shape. Orion's belt will unravel. Even the North Star will wander from its place. The sky you know is temporary. But again, you wouldn't know it just by looking. That's the strange tension of cosmic motion. How something so fast can feel so still. How the entire solar system can be sweeping through the galaxy like a ship through an endless ocean, and yet to us, it feels like the stars are standing still. That's because we're moving with them. The stars around us, at least those close by, are part of the same spiral dance. It's like looking out the window of a plane mid-flight and watching the clouds move with you. Everything looks still until something shifts, until you pass a reference point that reveals the truth. In space, those reference points are hard to find. Most are too far, too dim, too slow to show their hand. But we do see hints. We can measure how light stretches as stars move away, how it compresses as they approach. We can map their orbits, track their shifts, and chart the Sun's slow passage through the galaxy with increasing precision. Telescopes like Gaia are helping us draw a three-dimensional map of motion. And what we're finding is that nothing is ever really at rest. Every star has its own velocity, its own path, its own relationship to the galaxy's gravity. And yet, it all holds together. The arms of the Milky Way swirl not as fixed structures, but as patterns, density waves that stars drift in and out of. It's not like cars on a racetrack. It's more like dancers in a flow of movement, joining and parting and swirling together through time. The spiral shape you see in illustrations is not made of permanent stars. It's made of rhythm. And in that rhythm, you live. On a small blue world, orbiting a yellow star, moving at impossible speeds through something too large to see. But you don't have to feel the motion to know it's there. You can feel its presence in other ways. In the age of rocks, in the direction of comets, in the trails of ancient light, in the quiet fact that the sky above you was never meant to be still. It only seems that way because you've never known anything else. It's easy to imagine the galaxy as a kind of origin point, the place where everything began, a spiral womb from which stars and planets and life itself slowly emerged. But the truth is stranger than that. The Milky Way didn't arrive fully formed, and not everything within it was born here. In fact, some of the stars you see in the sky, dim ones, wandering alone in the halo, barely visible even to our best telescopes, are older than the Milky Way itself. They came before the spiral, before the shape, before there was a Milky Way to speak of. These stars don't live in the bright, busy disk where new stars are born. They drift in the galaxy's outer reaches, in the vast spherical halo that surrounds the spiral like a faint, invisible shell. Their paths are long and slow, tilted away from the galactic plane, as if they were never part of its rotation to begin with. They orbit in loops that don't match the rest of the galaxy's rhythm, as if moving to a song from some other time. They are small, low in mass, and faint in light, but what they lack in brilliance, they make up for in age. Many are more than 13 billion years old, formed just a few 100 million years after the Big Bang, at a time when the universe itself was still settling into its shape. Back then, the first stars were forming from clouds of nearly pure hydrogen and helium, unpolluted by the heavier elements forged in later stellar generations. The early universe didn't yet know how to make stars like our sun. It only knew how to form the simplest ones bare, ancient, and long-lived. These early stars don't contain much in the way of metals, at least not by astronomical standards. In this context, metals refers to anything heavier than helium, carbon, oxygen, iron, gold, things made in the hearts of dying stars. And the fact that these halo stars lack them tells us something critical. They were born before much of that alchemy had begun, before galaxies had merged, before supernovae had seeded the cosmos with new ingredients. They are pure in a way that almost nothing else in the universe still is. Some of them, astronomers believe, were born in tiny primordial galaxies, fragmentary little clumps of matter that never grew large enough to become full spirals. Over billions of years, these smaller galaxies were drawn toward the Milky Way's gravity. They were consumed, their stars scattered and flung into the halo like relics from a forgotten era. Others may have formed in the earliest threads of the Milky Way itself, before it had coalesced into a disk, back when it was just a loose cloud of gas, slowly collapsing under its own weight. We think of the Milky Way as a stable structure, a spiral with arms, a center, a plane. But that structure was built piece by piece over time. It wasn't born, it was assembled, shaped by collision, drawn together by gravity, stitched from fragments of older things. These ancient halo stars are the evidence. They are like fossils from a time before order, still glowing faintly, still circling the heart of a galaxy that grew up around them. Their orbits are strange and lopsided. Some loop far above and below the disk, while others trace long ellipses through the galaxy's outer dark. They don't follow the usual rules, and that's exactly why they're so valuable. By studying their motion, their composition, their place in space, astronomers can piece together a story that no longer exists in any other form. A story of what the early universe was like, what kind of stars it made, how matter first gathered, and how the first light was born. These stars are not just old, they are messengers, carriers of a history we can't witness any other way. Their light has been shining since before the Milky Way had arms, before the Earth was a dream, before the sun itself existed. They have survived for longer than most galaxies remain unchanged, and they continue to drift, quietly, through the vast halo, unbothered by the crowded, swirling chaos of the disk below. When you look up at the night sky, most of what you see is recent. Young stars, nearby ones, things bright and close enough to burn through the veil of distance. But above them, beyond them, are stars so old they remember a time before the Milky Way. Their orbits don't lie in the same plane. Their chemistry doesn't match. And their existence reminds us that even our galaxy had a childhood, and that childhood had ancestors. We live in a galaxy made of memories, some new, some ancient, some so old they don't quite fit. And drifting through its halo, like quiet ghosts, are stars from a time before names, before patterns, before the spiral. They are not leftovers, they are the beginning. Galaxies don't just live, they grow. And in the vast, cold architecture of the cosmos, growth often means taking something else apart. The Milky Way, like many galaxies its size, is not a peaceful island drifting gently through space. It's a predator, a slow-motion devourer of smaller galaxies, consuming them not in flashes or bursts, but in drawn-out collisions that unfold over billions of years. We often imagine galaxies as serene spirals, graceful and untouchable. But beneath that elegance is violence, a history of absorption and hunger written into the very stars we see. The evidence is all around us. Stars that don't belong where they are. Streams of light stretched across the sky in faint arcs. Orbits that wobble and twist in directions that make no sense in a spiral built from scratch. These are the remnants of other galaxies, smaller ones that the Milky Way pulled in, tore apart, and digested. Some were shredded so completely that all that remains are scattered trails of stars, barely visible unless you know how to look. Others are still in the process of being eaten. One of the most dramatic examples is the Sagittarius dwarf galaxy, a tiny spheroidal satellite galaxy that has been orbiting us for billions of years. Or rather, it was orbiting. Each time it passed close to the Milky Way, our galaxy's gravity pulled a little more of it apart. Star clusters were stripped from its edges, its shape stretched and warped. Over time, Sagittarius dwarf lost so much of itself that it began to unravel, forming long, looping streams that now wrap around the Milky Way like threads of torn cloth. It's still being consumed, still falling inward. The process isn't over, it's just too slow for our eyes to follow. Then there's Gaia Enceladus. Unlike Sagittarius, which is still visibly clinging to the last shreds of its identity, Gaia Enceladus is already gone. But its bones remain. In 2018, data from the European Space Agency's Gaia spacecraft revealed a peculiar population of stars moving in strange, counter-rotating orbits. They weren't born in the Milky Way. Their chemistry was wrong, their motion all wrong, like dancers out of sync with the music. These stars were relics of an ancient collision, an entire galaxy that merged with the Milky Way around 10 billion years ago. The two galaxies didn't just brush past each other. They collided, tangled, and blended. Gaia Enceladus didn't survive the impact, but it left its stars behind, like sediment at the bottom of a deep sea. These aren't isolated events. Galactic cannibalism is not rare. It's the norm. The Milky Way has been feeding for most of its life, drawing in smaller galaxies from its surroundings, folding them into its structure, and growing stronger with every meal. This is how large galaxies form, not all at once, but in pieces, bit by bit, merger by merger. Each new addition reshapes the whole, adding mass, distorting the spiral, enriching the galactic halo with stars that remember a different sky. The stars that come from other galaxies often betray their origins in subtle ways. Some travel in streams that stretch across space like ribbons, remnants of tidal forces that pulled them from their homes. Others group together in clumps that refuse to disperse, bound by a common history and shared chemistry. And some remain in the halo, faint and solitary, orbiting far from the galactic disk, too old and too different to blend in completely. These stars are like fossils, preserving a record of the Milky Way's appetite. Even our own sun might carry scars from these ancient feasts. Its orbit is relatively calm now, but the solar system may have once passed through regions of space thick with debris from a shattered galaxy. Some theorists suggest that the influx of dark matter or gas from such encounters could have disrupted the outer solar system, nudging comets from distant reservoirs and triggering waves of impact on Earth. It's possible that entire chapters of our planet's history, the rise and fall of species, the timing of ice ages, even the early formation of the solar system itself, were shaped not just by what happened on Earth, but by the Milky Way's hunger in deep time. The idea of a galaxy eating others can feel surreal, but it's not a metaphor. It's a gravitational process, slow and intricate and inevitable. Small galaxies are pulled into larger ones, their stars unraveling into streams, their cores swallowed, their histories erased or absorbed. The Milky Way, for all its quiet beauty, is part of that process, a survivor of countless collisions, a product of cosmic violence, and it's not finished yet. Right now, our galaxy is surrounded by dozens of dwarf galaxies, many of them in various stages of disruption. Some are bound tightly, orbiting close. Others linger farther out, waiting to be drawn in. Over the next few billion years, more of them will be consumed, pulled apart, and folded into the galactic disk or halo. The stars will scatter, the structures will vanish, but their presence will remain in the movement of orbits, in the chemical fingerprints of old light, in the patterns that astronomers continue to uncover, like archaeologists of the sky. And in time, something larger looms. The Milky Way itself is on a path toward another massive galaxy, Andromeda. The collision is still billions of years away, but it is coming. When it happens, the two galaxies will merge in a slow, spectacular fusion. Stars will pass through one another like ghosts, but the shapes will distort, arms will twist and tear, and in the end, a new galaxy will form larger, stranger, and born from the ruins of two. So when you look up at the stars, you're not just seeing light. You're seeing layers of history, some born here, some captured, some survivors of ancient galactic battles. The night sky is not a still map. It's a tapestry of motion, memory, and quiet consumption. The Milky Way is not just where we live. It's what we've become, a part of a living structure built on the remnants of other worlds. Imagine watching a spinning wheel, one that stretches for 100,000 light years, its arms coiled with stars and dust, its heart heavy with ancient light. You'd expect it to turn, like any ordinary wheel, faster at the center, slower at the edges. Its motion governed by the same gravity that makes planets orbit stars and apples fall from trees. But the Milky Way doesn't spin like that. Its outer edges, where stars should be barely holding on, moving sluggishly, dragging behind, are racing at nearly the same speed as those near the core. It moves like a wheel that shouldn't work. And for a long time, no one could explain why. If our galaxy followed the rules Isaac Newton left us, the stars farther out should be governed by weaker gravity. The farther you are from the mass at the center, the slower you orbit. That's how it works in our solar system. Mercury moves fast, hugging tight to the sun, while Neptune crawls along at a distant pace. This made sense. It matched observation. Until astronomers began measuring the rotation speeds of stars far from the center of the Milky Way. They expected those distant stars to drift slowly, barely tethered to. the galactic core. Instead, they were moving just as quickly as stars much closer in. It was as if the outer galaxy had extra gravity, more than what could be explained by the visible matter, more than what could be seen in stars, planets, gas, and dust combined. The curve of rotation, when plotted, didn't fall off like a hill sloping down. It stayed flat, and that made no sense. It wasn't just the Milky Way. Other galaxies showed the same strange pattern. Their outer stars were moving too fast. According to Newtonian physics, they should have flown off into space, like rocks spun from a sling. But they stayed. They held together, as if something invisible was anchoring them in place. That mystery became the foundation for what we now call dark matter, a kind of mass we cannot see, cannot touch, but know must be there. Because without it, the galaxy unravels. Without it, the stars don't stay. Without it, the Milky Way's great spinning form would collapse or fly apart. But with it, the numbers work. With it, the rotation curve flattens as expected. And so we say, dark matter must exist. Something unseen is giving the galaxy its structure, holding it together like scaffolding in the dark. This idea reshaped our understanding of the universe. It suggested that most of what exists, maybe over 80% of all mass, is invisible, not just to the eye, but to the entire spectrum of light. Dark matter doesn't emit, reflect, or absorb light. It doesn't shine. It doesn't glow. It passes through us unnoticed, like wind through a screen, and yet its gravity is felt everywhere. The Milky Way, as it turns out, is surrounded by a vast halo of this dark matter, stretching far beyond the spiral arms we can see. It is this halo that explains the galaxy's strange rotation. It's why the outer stars move so fast. It's why the whole system stays intact. Without it, the math fails. The wheel breaks. The structure collapses. And yet, dark matter remains one of the greatest enigmas in science. We've never directly detected it. We can't isolate it in a lab. We don't know what it's made of. There are theories weakly interacting massive particles, axions, modifications to gravity itself, but none have been confirmed. We only know it's there because of what it holds, because of what it prevents from falling apart. And that raises an unsettling thought. The galaxy, as we know it, should not exist without this unseen mass. The stars we see, the structure we map, the spiral we admire from afar, none of it should stay together if it were made only of visible matter. It's the dark, silent foundation beneath everything that makes it all possible. It's like living in a house you didn't build and discovering the beams holding up the ceiling are made of something you can't see or touch. But you know they're there because the roof hasn't fallen in. So the Milky Way spins, defying old expectations, balancing on gravity we can't account for without invoking the invisible. The stars continue their orbits, the arms swirl in slow grace, and we remain suspended in this quiet mystery, not falling, not flung into the dark, kept, somehow, by something we cannot name. And still, the galaxy moves, relentlessly, silently, like a wheel that, by all rights, shouldn't work, but does. Far beyond the stars you see at night, past the soft glow of the Milky Way and the glittering dust lanes that cross the sky, a silent giant is drawing closer. It's called Andromeda, the nearest spiral galaxy to our own, and it is not just a distant neighbor drifting aimlessly in the dark. It is falling toward us, slowly, inexorably, on a path that was set long before humans knew how to look up and wonder. Right now, Andromeda is about 2.5 million light-years away, a smudge in the sky if you know where to look. But it's not standing still. It's moving toward us at nearly 400,000 kilometers per hour. And one day, it will arrive. Not in our lifetimes, or even in the span of all human history so far. The collision is still about 4 billion years away. It's hard to imagine that kind of time harder still, to picture the sky of the far future, where stars we know today will be gone and constellations will have unraveled. But the timeline is real, and the course is set. The Milky Way and Andromeda are locked in a gravitational embrace, slow and invisible to us, but moving all the same. When we hear collision, it's easy to imagine chaos, explosions, destruction, the obliteration of stars and planets caught in the impact. But space is vast, and galaxies are mostly empty. Stars are so far apart that even when two galaxies collide, the odds of any two stars actually striking each other are vanishingly small. It's not a crash in the way we think of crashes. It's more like two vast swarms passing through one another, their shapes distorting, their gravity weaving together in slow motion. What will happen is a reshaping. The delicate spiral arms of both galaxies will stretch and warp, drawn into long tidal tails. Their cores will pass by each other, then swing back again, pulled together over time by their mutual attraction. The stars within each galaxy will be flung into new orbits, some hurled into the intergalactic dark, others pulled inward. Clouds of gas will collide and compress, sparking new waves of star formation, brilliant, short-lived stars burning hot and fast. And over the course of a few billion years, the two galaxies will finally settle into one. The result will not be a spiral. It will be something more like an elliptical galaxy rounder, less structured, glowing with the remnants of two once distinct systems now merged into one. Astronomers already have a name for this future object: Milkomeda, a blending of Milky Way and Andromeda, a monument to what came before. And Earth? Our planet may still exist by then, though the sun will be nearing the end of its life, growing hotter and more unstable as it approaches its red giant phase. Long before the merger is complete, Earth may already be uninhabitable, but the solar system itself could survive the galactic collision, flung into a new orbit far from the merged core, or sailing along in one of the stretched outer streams. The night sky, though if there are still eyes to see, it will look very different. At first, Andromeda will grow brighter in the sky, turning from a faint smudge into a glowing disk. Then, over millions of years, its stars will begin to spread across the heavens, mingling with our own. There may come a time when the sky is filled with two galactic cores, ours and Andromeda's burning side by side, casting pale light across the night like twin moons of ancient fire. Constellations will be torn apart. New ones will form. The map of the stars will become a shifting canvas, a record of gravity painting across time. Eventually, after the final pass, when the galaxies have fully merged and settled into equilibrium, the sky will quiet again. The brilliant chaos will fade, and the new galaxy will stabilize. The stars will find new rhythms, and the memory of the collision will remain only in the patterns of their orbits, in the diffuse shell of gas and stars left swirling at the edges. We are used to thinking of galaxies as eternal, fixed, but nothing in the universe holds its shape forever. The spiral of the Milky Way is temporary. Andromeda's form is already changing. Over cosmic time, every galaxy is a story in motion, its chapters marked by collisions and mergers, births and deaths. Our own chapter is still being written, but the next one is already on the way. There's something beautiful in that inevitability, the knowledge that we're part of something larger, that even our galaxy has a destiny written in the stars, that long after we're gone, long after the names and borders and stories of our world have faded, the Milky Way will still be moving toward its future, slowly falling into a new shape under a sky filled with stars not yet born. And in that future sky, someone or something might look up, see the bright arcs and twin cores above, and wonder what it all means. Just as we do now, at the heart of the Milky Way, in a place where stars circle like moths around a flame, there is something we cannot see. Not directly. It doesn't glow or shine or cast light of its own. It doesn't rise or set or flicker in the dark. And yet it is one of the most massive things in our entire galaxy. A supermassive black hole, tucked away in the dense, dust-shrouded core, known by a deceptively quiet name, Sagittarius A*. From where we are, 26,000 light-years away, the center of the galaxy is hidden behind clouds of gas and dust, so thick they blot out visible light entirely. But with the right instruments, infrared telescopes, radio dishes, and X-ray observatories, we can peer through that veil. What we see is strange. Stars whipping around an invisible point at incredible speeds, arcs of gas flaring suddenly with bursts of high-energy radiation. The space around this unseen center is distorted, as if gravity itself is being pulled into a whirlpool of silence. Sagittarius A* is small on the sky, barely larger than the orbit of Mercury, but it contains over 4 million times the mass of our Sun. It sits in the very center of the galaxy like a buried anchor, not drifting, not wandering, but holding court over the crowded stellar swarm around it. And though it is quiet now, its history speaks of something much louder. We know it's there, not because we can see it directly, but because of what it does to the things around it. For decades, astronomers have tracked a set of stars near the galactic center, watching as they move in tight, fast orbits around an empty patch of space. One of these stars, called S2, completes a full loop every 16 years, an incredible feat considering its path is hundreds of times larger than Pluto's. But even at that distance, it's still bound to Sagittarius A*, pulled by a gravity so intense that nothing, not light, not time, not information can escape once it crosses the edge. Occasionally, the black hole flickers, not in visible light, but in X-rays and radio waves. A sudden flare, a momentary brightening. These are thought to be caused by small clumps of matter falling inward, heating up as they spiral closer, releasing energy just before they vanish forever. For a moment, the black hole speaks briefly, wordlessly, and then falls silent again. But it hasn't always been so quiet. There's reason to believe that Sagittarius A* was once far more active. Billions of years ago, when the galaxy was younger, it may have fed more greedily, pulling in vast clouds of gas and dust, igniting into a quasar, a beacon of radiation so powerful it could be seen across the universe. In those early epochs, galaxies with supermassive black holes at their centers often glowed with terrifying intensity, their light outshining every star within them. Today, we see quasars in distant galaxies, frozen in ancient light. But here, in the Milky Way, our own quasar has long gone dormant, and yet the potential remains. If enough material were to fall toward the center, perhaps triggered by a collision with another galaxy or a sudden influx of gas, Sagittarius A* could awaken again. The quiet core could become a furnace. The gentle flare-ups we see now could swell into storms of radiation. The galaxy's heart, which now appears calm, could once again blaze with energy. There's a strange kind of beauty in its silence, a reminder that not all power announces itself, that the most massive object in our galaxy, the one whose gravity curves the space around it like a spoon in honey, is also one of the most invisible. It sits there, unmoving, shaping the orbits of stars, sculpting the dynamics of the galactic core, watching without eyes as time unfolds around it. And yet, for all its gravity, it doesn't define us. The Sun doesn't orbit Sagittarius A* alone. It orbits the mass of the entire galaxy stars, gas, dark matter, all distributed across the disk. The black hole at the center is vast, but not dominant. Its influence is profound, but limited. We are distant, out in the suburbs of the Milky Way, feeling only the faintest pull of that ancient gravity. Still, it's there, always, a kind of cosmic punctuation mark, ending the sentence of every orbit in the core. The stars that dance closest to it do so in tight ellipses, their paths bent and compressed by a force that shapes them like a sculptor, with unseen hands. And as we watch those stars spin, year by year, we learn more not just about black holes, but about space and time themselves. Because Sagittarius A times is not just an object, it is a test, a place where our understanding of physics begins to bend, where the rules we thought were firm begin to soften, where time runs slower and the line between space and mass becomes blurred. It is both a riddle and a key, and though we cannot see it, though we may never touch it or hear it or understand it fully, we know this much. At the center of our galaxy, there is a silence so deep it warps the light itself, and it holds everything still. In the quiet, swirling vastness of the Milky Way, most stars behave like they're supposed to. They orbit in long, slow curves, held gently by the gravity of hundreds of billions of their neighbors. Their paths are stable, their lives, in cosmic terms, uneventful. But scattered through the darkness, there are outliers, a rare breed of stars that do not orbit, they flee. Launched from the galaxy at blistering speeds, they race away from everything they've ever known, moving so fast that the gravity of the Milky Way can no longer pull them back. These are the hypervelocity stars, the runaways, the outcasts. They aren't born this way. No star begins its life with the kind of speed needed to escape an entire galaxy. They're accelerated, slingshotted by forces extreme enough to break even the strongest gravitational bonds. One of the most dramatic sources of such speed is the supermassive black hole at the center of the Milky Way. It doesn't just hold stars in place, it can fling them out, like sparks from a grinding wheel. The process begins with a binary system, two stars orbiting one another in a tight dance. If this pair ventures too close to Sagittarius A*, the tidal forces of the black hole can tear them apart. One star falls inward, swallowed into the silence. The other is ejected, suddenly freed, and hurled outward at speeds that can reach millions of kilometers per hour. It's like watching a coin flip, where one side disappears forever and the other is launched into the void. Hypervelocity stars don't just drift away, they scream across the sky, moving so quickly that they outpace the galaxy's ability to keep them. Once they reach a certain distance, the Milky Way's gravity lets go. They become unbound, sailing alone through intergalactic space, growing ever more distant, their path unalterable, their past lost behind them, and they are fast. Some travel at more than 1,000 kilometers per second, fast enough to circle the Earth in less than a minute. Fast enough to escape not just the Milky Way, but any realistic hope of return. From a distance, they look like ordinary stars, but their motion betrays them. They move with urgency, a kind of reckless speed that nothing born from stillness could explain. Other mechanisms can produce these cosmic fugitives as well. Supernovae, for instance. If a massive star explodes while bound to a companion, the force of the blast can eject the surviving partner at incredible speeds. These runaway stars aren't quite as fast as the ones launched by black holes, but they still carry the violence of their origin. They are reminders that even in death, stars can impart motion, can transfer their energy to others in a final, catastrophic push. And there are even stranger cases, where galaxies themselves collide, and gravitational chaos flings stars from the outskirts into open space. These stars are tossed from their home systems not by explosions or black holes, but by the slow tidal forces of merging galaxies, a kind of drawn-out eviction from a place they never expected to leave. Once unbound, a star's journey becomes endless. It will not slow down. Nothing in intergalactic space is dense enough to sap its energy. It will drift forever through the darkness between galaxies, carrying its light into regions where no one is likely to ever see it. If it has planets, they too are cast into exile, entire solar systems hurtling silently into the void, with no sunrises or neighbors, only the long, cold dark expanding around them. These rogue stars are rare, but not impossibly so. We've found a handful already, moving through the outskirts of the Milky Way, their trajectories aimed away from the core, their speeds too great to keep them here. They are travelers without destination, stories without a final chapter, slipping silently beyond the reach of their birthplace. And what becomes of them? Eventually, they fade. Like all stars, they burn through their fuel, though at a pace determined by their size and type. A small star might glow for trillions of years, a larger one, just a few million. But when the end comes, whether as a white dwarf, a neutron star, or in a final burst of supernova, they will meet it alone. No galaxy to cradle them, no cluster to call home. Just the endless stretch of black around them, unbroken and unclaimed. It's a strange kind of fate, to begin life in the dense comfort of a galactic nursery, surrounded by light and motion, and to end it drifting alone through a space so vast it defies comprehension. But these stars are real. They move among us, some still inside the galaxy, some already too far to see. They are the exceptions that prove the rules, the sparks that escape the fire. And in their motion, they tell a story that galaxies usually hide, that even in a system built on balance and rotation, chaos can intervene, that gravity can both hold and release, that even stars, for all their mass and momentum, can be cast out, not because they failed, but because the universe is not still, and nothing, not even a galaxy, is forever safe from being reshaped by the forces it contains. From a distance, it's tempting to imagine the Milky Way as a perfect spiral, flat, elegant, symmetrical, like the designs drawn into seashells or the patterns of galaxies on posters. That's the way it looks in textbooks, simplified for the sake of clarity. A great pinwheel in space, turning quietly with its arms stretched wide. But real galaxies are not so tidy, and the Milky Way, for all its grace, is not flat. Its disk is warped, curved at the edges, like a vinyl record left too long in the sun. It ripples, bends, and twists in a way that defies the perfect spiral we often picture in our minds. This warping isn't just a visual oddity, it's a structural feature, one that affects stars, gas, dust, and even the way gravity behaves across the galaxy. If you could rise far above the galactic plane and look down, not just in 2 dimensions, but in 3, you'd see the disk curving upward on one side and downward on the other, like a vast sheet of metal gently flexed by unseen hands. The arms still spiral, but they don't lie flat. They lift and dip, wave-like, across the void. And that begs the question, what caused it? Warping a galaxy takes an enormous amount of energy, and the most likely explanation is interaction. The Milky Way, as it turns out, doesn't live alone. It has companions, smaller satellite galaxies like the Magellanic Clouds that orbit around it, bound by gravity, yet moving on their own unpredictable paths. These satellites tug on the Milky Way's outer disk, like moons pulling on the oceans of Earth. Over time, their gravitational nudges have added up, setting the stars and gas in motion, creating a ripple that spans tens of thousands of light years. But it's not just a matter of pull. The way these companions move, the way they orbit and interact with the dark matter halo surrounding the Milky Way, adds complexity. The galaxy isn't just a disk of stars, it's embedded in a larger, invisible sphere of dark matter. And that halo can also shift and flex in response to the satellites. As the dark matter is disturbed, it pulls the visible galaxy with it, like a flag caught in a shifting wind. This interaction creates a strange kind of choreography. The disk warps not uniformly, but with variation. The gas, being lighter and more responsive, bends more dramatically than the stars. The outer regions lift and fall in, slow, rhythmic motion. And this warping isn't frozen. It evolves over time, changing shape with each orbit, with each gravitational encounter, like ripples spreading across the surface of a pond after a stone is thrown in. For a long time, we couldn't see this clearly. From our position within the galaxy, it's hard to get perspective. We live inside the disk, and from here, everything seems relatively flat. But by mapping the positions of stars in different regions, by tracing the motion of hydrogen gas, and by looking at how starlight dims or shifts as it moves through space, astronomers have pieced together a fuller picture, and what they've found is undeniable. The Milky Way is bent. Some parts of the disk rise nearly 5,000 light-years above the galactic plane. Others dip just as far below. The warp forms a kind of S shape when viewed edge-on, graceful but uneven. This is not a minor feature. It affects a significant portion of the galaxy, and its origins are still not fully understood. Some theories suggest an ancient collision, perhaps with a now vanished dwarf galaxy, whose impact sent waves spiraling through the disk. Others focus on the Magellanic Clouds, especially the Large Magellanic Cloud, which may be more massive than once thought, and is currently on a fast, plunging trajectory toward the Milky Way. But there's something deeper beneath it all, a sense that the Milky Way is not a static object, that it is alive in its own way, breathing, moving, responding to forces we can only partially trace. This warping is not a flaw, it's a consequence of living in a dynamic universe where even the most massive structures are in constant dialogue with their surroundings. And when you think about it that way, the warp becomes beautiful. It's a record of motion, a signature of history. Each bend and twist tells a story of what the Milky Way has touched, what it's endured, and what it's still becoming. It's the kind of imperfection that only makes something feel more real, like the craters on a moon or the wrinkles in an ancient tree. Even the stars are affected. Their orbits are altered by the shifting mass, especially in the outer regions where the warp is strongest. The path of a star might rise and fall across eons, tracing the curve of the disk like a ship riding swells on a slow-moving ocean. This means that the warping doesn't just shape the galaxy's appearance, it shapes its future, guiding the flow of matter and the birth of new stars. So when you look up at the Milky Way, whether from a mountaintop or through a telescope, it's worth remembering that you're seeing only one layer of a more complex whole. The light we see is flat, because we are flat, but the galaxy is not. It curves above and below, a silent, enormous wave suspended in space, sculpted by gravity and time. The Milky Way is warped, not broken, bent, not damaged. And in that warping lies a quiet truth, that nothing in the universe stands still, not even a galaxy, not even this. If you step outside on a clear night, far from city lights, and tilt your head back to take in the stars, it feels like you're looking at everything. The heavens open up above you in a velvet spread, pinpricked with white and blue and gold. The Milky Way stretches across the sky like a soft seam of light, as if the cosmos itself were gently pulling apart to show its inner threads. It's humbling, breathtaking, this sense that you are seeing the galaxy laid bare before you. But the truth is far stranger and far quieter, because nearly everything you're seeing isn't there. What you witness with your eyes, those glittering constellations, the cloudy haze of the galactic core, the scattered diamonds of star clusters, that's only the surface. A veneer, an illusion so convincing we built entire mythologies around it. But in reality, most of the galaxy is hidden, veiled behind dust, embedded in gas, wrapped in shadows, and held together by something we cannot even see. We see stars because their light travels, slipping through the vastness until it reaches the Earth. But the Milky Way is thick with interstellar dust, tiny particles of carbon and silicates drifting in clouds that stretch for hundreds of light years. These clouds are cold, dark, and dense, and they block visible light with remarkable efficiency. The dust doesn't simply make the galaxy dimmer, it reshapes what we believe we're looking at. Great swaths of stars, entire arms of the spiral, are obscured from view. Even the galactic center, where the mass of stars is greatest, is heavily cloaked in dust, revealing itself only in slivers, Only when viewed in special wavelengths like infrared or radio. From our vantage point on Earth, this effect is profound. Astronomers estimate that of all the stars in the Milky Way, estimated to be between 100 and 400 billion we can see, with the naked eye, perhaps 5,000. And of those, only a few thousand are visible from any one place at any one time. That's not a percentage. That's a fraction of a fraction of a fraction. We are seeing less than 0.00003% of the galaxy, a thin film of light stretched across an ocean of dark. And yet, the illusion holds. The stars we do see are close, cosmically close. Most lie within just a few hundred light-years of Earth, a thin bubble of visibility inside a disk that is over 100,000 light-years wide. It's like trying to understand the ocean by looking at the surface of a tide pool. You can describe the ripples, you can trace patterns in the sand, but the deep, vast thing with the true thing remains hidden beneath. Beyond the stars and the dust, there's something even stranger, something that doesn't glow, doesn't shine, doesn't reflect, but outweighs everything we can see. It's called dark matter, and it makes up the majority of the galaxy's mass. We know it's there because of gravity. The stars at the edge of the galaxy orbit far too quickly to be held in place by the mass we can account for. They should fly off, spinning away into space. But they don't. They stay bound, as if the galaxy is heavier than it appears, wrapped in a cloak of invisible weight. This dark matter doesn't interact with light, doesn't clump or burn or collapse into stars. It moves through the galaxy like a ghost, affecting everything but revealing nothing of itself. And it is everywhere. The Milky Way, like most galaxies, is enveloped in a vast halo of dark matter stretching far beyond the edge of the visible disk. It extends above and below, cradling the galaxy in a structure we cannot see, but that shapes everything we do. That means when we look up and see the stars, we're not just missing the ones hidden by dust. We're missing the entire framework that holds the galaxy together. What we see is not the structure, but the decoration, the sparkles on the edge of something massive, ancient, and almost entirely invisible. Even the way the Milky Way appears in the night sky, arched, luminous, steady, is deceptive. We are inside it, looking outward, like standing in a forest and seeing trunks and branches in every direction. We mistake our local perspective for the whole. The galaxy is flat because we see it edge on, bright in a band because we're gazing through the densest part, and fractured, incomplete, because the dust slices through it like veins of charcoal across a lantern. To see the galaxy more clearly, astronomers use instruments that extend our vision. Infrared telescopes can peer through dust to reveal the stars behind it. Radio telescopes trace hydrogen gas, mapping the shape of spiral arms invisible to our eyes. X-ray observatories catch flares from collapsed stars, hinting at the remnants hidden in the dark. Bit by bit, they stitch together a picture more complete, more honest one, that shows the Milky Way not as a glittering slice of sky, but as a dynamic, multi-layered system filled with light we cannot see and mass we cannot measure directly. And yet, even with all our instruments, even with all our maps and models, we still grasp only a portion of what the Milky Way truly is. The visible stars are not its body, they are its skin. The rest, the bones, the blood, the weight is concealed in shadows, where no telescope can yet follow. But there is a kind of wonder in that too. To live inside something so enormous and yet so hidden is to be reminded of how little we know. It's a whisper from the universe that mystery still exists, that behind every point of light is a sea of silence, that beyond what we see, there is more. Always, there is more. The space surrounding the Milky Way is not empty. Beyond the glowing spiral arms and the quiet star fields we see from Earth, beyond the curtain of dust and the cradle of light, lies a halo, a vast, invisible sphere of influence that stretches far beyond what we usually picture when we imagine a galaxy. It is diffuse and cold and dim. But if you could pull back far enough and slow time just enough, you'd see it for what it is. A graveyard of galaxies, a sky threaded with ghosts. These are the remnants of long-lost travelers, smaller galaxies that wandered too close to the Milky Way, caught in its gravitational tide. Over millions of years, they were pulled apart, not in an instant, but slowly, stretched and dismantled star by star. What remains are stellar streams, long, faint ribbons of stars that arc and twist through the galactic halo like ink trails in water. They are not easily seen, not with the naked eye, not even with most telescopes, but they are there, whispering the history of cosmic encounters written not in words, but in motion. Detecting them is a quiet art. These streams do not announce themselves. They blend into the background, their stars as old and dim as the ones around them. But their movement is different. They don't orbit like ordinary stars. They travel together, aligned like beads on a broken necklace, remnants of something once whole. By tracking their positions, their velocities, their slight shifts in light and color, astronomers can tease them out, mapping the sky's hidden architecture, one ghost at a time. Some of these streams stretch for tens of thousands of light years, looping around the galaxy in vast arcs that have no beginning or end. They drift through the halo in paths inherited from the galaxies that birthed them, still following the echoes of gravitational collapse, even though the original systems are long gone. In a sense, they are fossils, frozen records of past collisions, preserved not in stone, but in starlight. One of the most well-known of these is the Sagittarius stream, the shredded remains of the Sagittarius dwarf galaxy, which ventured too close to the Milky Way and began its long, slow unraveling. Today, its stars are scattered in a looping path that winds around our galaxy's outskirts, wrapping it like a ribbon. There's no single moment when Sagittarius ceased to be. It faded over time, stripped layer by layer, until what was once a distinct galaxy became just another part of the halo diffuse, forgotten, but still there. These streams are more than celestial curiosities. They are maps, their shapes, their distribution, the way they wrap and twist and fray, these all reveal the gravitational structure of the Milky Way itself. Like iron filings revealing the shape of a magnetic field, stellar streams trace the unseen contours of the galaxy's mass, including the vast halo of dark matter that surrounds and penetrates it. Where the stream curves, the gravity is deeper. Where it splits, the history is more violent. And when it disappears, something may have been waiting there in the dark. By studying these structures, astronomers can glimpse the unseen, not just the past, but the shape of the galaxy's hidden skeleton. The Milky Way, like all galaxies, is built not just from what we see, but from the collisions and mergers that came before. Every stellar stream is a scar, every arc of stars a memory of something that once tried to orbit and failed. The halo is not still, it is filled with motion, and in that motion we find history. Some streams are fresh, their stars still tightly grouped, moving in clear formation. Others are ancient, barely distinguishable from the background, spread so thin that only statistical models can reveal their presence. Together, they form a web, a net of light stretched across the sky, built from the remnants of smaller galaxies that fell into the Milky Way's embrace and never escaped. And the process continues. New dwarf galaxies still orbit the Milky Way. Some are falling inward now, their stars beginning the slow migration from order to chaos. In the coming billions of years, they too will be pulled apart, their cores disrupted, their outer stars peeled away and fed into the rather growing halo. The streams will lengthen, new ones will form. The structure will grow ever more complex, ever more rich with the stories of what was. There's a kind of solemn beauty in that the galaxy doesn't just destroy, it remembers. That even as smaller galaxies are consumed, they leave traces, threads of themselves woven into the larger whole. The Milky Way is not a single entity. It is a chorus of collisions, a cathedral built from the ruins of others, and the stars that drift through its halo are the silent congregation, still moving, still shining, long after their homes have vanished. To look for these streams is to look for the history beneath the surface, not the brilliant spiral arms or the bright young clusters, but the forgotten paths, the faded trails of stars that no longer belong to any single system. They are exiles, but they are not lost. They are the fingerprints of a galaxy in motion, left behind by encounters we can only reconstruct by their lingering evidence. So when we speak of the Milky Way, we must remember it is not just a place of birth, but a place of burial, a resting ground for the galaxies it has devoured. And yet, somehow, those ghosts endure, not in silence, but in motion, not in grief, but in memory, curved through space, dancing still, just beyond the edge of what we see. If you could rise far above the galaxy and look down not as a stargazer on Earth, but as something drifting in silence, 100,000 light-years high, you'd see the Milky Way as a vast whirlpool of stars, dust, and gas, spiraling slowly in a cosmic ballet. 4 great arms curl outward from the center, elegant and massive, like the arms of a hurricane wrapped in light. And nestled not in one of those great arms, but in a smaller, quieter lane between them, is where we live. A modest, unassuming stretch called the Orion Spur. The Orion Spur isn't grand. It isn't one of the galaxy's dominant structures. It lies between 2 of the major arms, the Perseus arm on one side and the Sagittarius arm on the other, like a bridge of stars tucked into the middle of traffic. At just a few thousand light-years wide, it's a minor feature in a galaxy over 100,000 light-years across. A backroad in a city of highways, a side street in a metropolis of light. And yet, somehow, it's home. Our entire solar system, every comet and moon and planet we've ever named, resides in this quiet spur. Our sun orbits the galactic center from within this unassuming branch, trailing a small entourage of worlds as it circles the Milky Way every 230 million years. From this place, we've launched telescopes, built theories, sent probes into the void. From this thin sliver of stars, we've peered outward and tried to make sense of the whole. But why here? Why does our star sit in a minor arm, rather than in the bright, crowded grandeur of the major spirals? The answer may be less a coincidence than a quiet stroke of fortune. The major spiral arms are brilliant and chaotic. They are dense with gas and dust, rich with star-forming regions that blaze with newborn heat. In those arms, stars are born in swarms, massive, short-lived giants that die in violent supernovae, flooding their surroundings with radiation and shock waves. These places are beautiful, but dangerous. The environment is harsh, ever-changing, unpredictable. The Orion Spur, by contrast, is calm. It's relatively sparse, with fewer massive stars and less turbulent activity. It doesn't blaze so brightly, but that may be why we're here at all. Life, especially life as delicate and time-hungry as ours, needs stability. It needs long, quiet ages without constant bombardment or disruption. A place where a star like the sun can burn for billions of years, unbothered by the frenzy of stellar birth or death. In that sense, the Orion Spur is not just our address, it might be our sanctuary. This region has likely shielded Earth from many of the galaxy's more dangerous neighborhoods. We pass through denser areas from time to time, as our solar system meanders in its orbit, but for the most part, we've remained in the gentler outskirts, far enough from the center to avoid its gravitational madness, but close enough to the spiral arms to gather the heavier elements needed to form rocky planets and complex chemistry. It's a delicate balance, proximity without peril, richness without ruin. And when we compare our location to other regions of the galaxy, the uniqueness becomes even clearer. The inner galaxy, near the bulge, is older and more crowded. Stars there are packed tightly, and the risk of close encounters, gamma-ray bursts, or destabilizing radiation events is much higher. Farther out, in the thin outer disk, the metallicity drops. Fewer heavy elements mean fewer chances to build complex worlds. But here, in the Orion Spur, we seem to occupy a kind of golden middle, a region rich enough to build us, and quiet enough to let us survive. It's easy to feel small in this context, to realize that even our corner of the galaxy is not a grand boulevard, but a side passage in an ancient and sprawling structure. And yet, there is something comforting about that too. The notion that from this humble spur, consciousness arose, that here, in a quiet place between chaos and emptiness, something began to wonder. From the surface of Earth, you can't see the arms of the galaxy stretching out around you. You can't trace the curl of the spiral, or point toward the center with any precision. The sky is a dome, not a map. But when we map the stars, when we trace their motions and their light, the pattern reveals itself slowly. The spirals emerge, the arms stretch outward, and there, tucked inside a gentle curve between giants, we find ourselves. The Orion Spur may not last forever. Galactic structure is fluid on large timescales. Stars drift, arms shift. Gravitational tides can stretch and scatter even the most established regions. Our sun is just passing through, part of a long migration that will carry it from one neighborhood to another over the eons. But for now, this is where we are. A spiral within a spiral, a brief moment of order in a sea of motion. It's not the center of the galaxy, it's not the brightest part, or the oldest, but sometimes it's the quiet places that last. Sometimes it's the subtle paths that lead to stories worth telling. And in the soft arc of the Orion Spur, just one among billions, a planet caught fire with life. And that life looked up and asked where it lived. Not all stars follow the rules. From our perch inside the spinning disk of the Milky Way, most stars appear to share a direction, a grand, sweeping rotation around the galactic center, aligned like dancers moving in the same graceful spiral. It's a rhythm so massive, so consistent, that we assume it must be universal. But hidden among the billions are outliers, stars that defy the flow, that orbit in reverse, moving backward against the grain, like fish swimming upstream in a cosmic river. These stars are rare, but they're real, and they are not mistakes. Known as retrograde stars, they loop through the galaxy in the opposite direction from most of their neighbors. Their motions stand out like scratches on glass, subtle but unmistakable. For a long time, they were curiosities, oddities tucked into data tables. But with time and better telescopes, astronomers began to notice patterns. These weren't just stars with strange orbits. They were clues. You see, the galaxy wasn't born whole. It grew, piece by piece, devouring smaller galaxies that wandered too close. Each merger added new stars, new gas, new motion. Some of those smaller galaxies had orbits aligned with the Milky Way's spin, and when they merged, their stars blended in. But others came in at angles tilted, skewed, or even spinning the other way entirely. And when those galaxies were torn apart, their stars kept the memory of that motion. Retrograde stars are fossils of these ancient collisions. They don't just orbit backward. They drift through the galaxy with a kind of historical defiance, as if refusing to be folded entirely into the larger system. Their paths are often elliptical or chaotic. Many loop far above and below the plane of the galactic disk, moving in wide, slow sweeps. Some belong to the halo, a spherical shell of stars and dark matter that surrounds the Milky Way, and their retrograde motion makes them stand out even there. One of the most striking examples of this comes from a galactic event known as Gaia Enceladus. It was the name given to a dwarf galaxy that merged with the Milky Way billions of years ago, long before Earth had cooled enough to form oceans. When it collided, it didn't just add stars to the halo, it reshaped it. It stirred the inner regions of the galaxy, creating ripples that still echo today. And the stars it brought with it, many of them now, on retrograde orbits, can still be traced. They move in coherent patterns, like a distant voice repeating itself in a sea of sound. Their motions aren't just unusual, they are readable. By tracking the paths of these stars, astronomers can reconstruct the history of the galaxy's formation. They can tell where the intruding galaxy came from, how massive it was, how it moved, and how it died. It's like reading the rings of a tree, but the rings are made of light and gravity and time. Retrograde stars are not errors in the structure, they are signatures. Their direction is not noise, it's memory. Not all backward-moving stars are the result of ancient mergers. Some are born in tidal streams, those long, looping arcs of stars that form when a smaller galaxy is pulled apart by a larger one. In some of those interactions, the shredded remains can be left on paths that circle the galactic center in reverse. It's a kind of stellar slingshot, where gravitational tides twist the orbit until it flips. These stars are still part of their original group, but the group itself is no longer whole. It's scattered, disassembled, drawn into long threads that wrap around the galaxy like silk unraveling from a cocoon. And then there are stars that may have been ejected from systems entirely, rogue stars that were flung by interactions with black holes or dense clusters, caught in a reversal of fate, and flung into orbits that run counter to the usual flow. Each one is a puzzle, a question mark spinning through the night. Together, they whisper that the galaxy is more complex than it appears, because in the grand scheme, the Milky Way is not a smooth wheel. It's a patchwork of parts, a layered story built from remnants. Its motion is dominant, but not total. Its structure is ordered, but not uniform. And hidden within that structure, like threads running against the weave, are stars that remember something different. A time before they were part of this galaxy. A place where the rules were not the same. To detect these stars, astronomers use careful measurements, tiny shifts, in position, in velocity, in spectrum. Missions like Gaia have mapped billions of stars with exquisite precision, and within that data, the retrograde stars stand out like reverse currents in a river. Not many, but enough to change the picture. They remind us that motion isn't always agreement, that in the deep history of the galaxy, conflict leaves scars, and that not all scars fade. When you look up at the stars, it's impossible to tell which ones are moving with us and which ones are pulling away, dragging old galaxies behind them. But they're there, scattered across the sky. Some rise in the east while others retreat. Some whisper of a past we cannot see, only infer. And in their backward paths, they carry the memory of long-lost homes. Even in the stars, history resists being erased. It lingers, it turns, it moves the wrong way, through a world that never stops spinning. High above and far below the flat, starry plain of the Milky Way, something immense is rising into space, two vast, ghostly structures billowing out from the center of the galaxy, like twin lanterns glowing faintly in the dark. They aren't made of stars, or dust, or gas, in the usual sense. They are made of energy, invisible to human eyes, but blazing in gamma rays, the highest energy light in the universe. These are the Fermi bubbles. They stretch for tens of thousands of light years, like hourglass-shaped lobes emerging from the galactic core, one ballooning above the plane, the other below. If our eyes could see in gamma rays, they would dominate the night sky, looming larger than the full moon, towering over the constellations like forgotten monuments. But instead, they remained hidden until recently discovered in 2010 by NASA's Fermi Gamma Ray Space Telescope, which had been quietly mapping the energetic sky. At first, the discovery was met with awe and confusion. These were not faint or ambiguous features. They were crisp-edged, bold, and massive. Their symmetry was striking, centered perfectly on the heart of the galaxy, extending roughly 25,000 light-years in either direction. That symmetry meant something had carved them. Something had pushed high-energy particles out into the halo in a way that was powerful, fast, and astonishingly organized. But what? Theories began to emerge. One possibility pointed to our galaxy's central black hole, Sagittarius A*, a supermassive object 4 million times the mass of our Sun. Today it sleeps, for the most part, emitting only occasional flickers of X-rays and the quiet swirl of gas near its event horizon. But black holes are not always so quiet. There are times when they wake, when they feed, when they blaze as quasars and eject matter in enormous, relativistic jets. Perhaps millions of years ago, Sagittarius A times did just that, devouring gas and stars, and belching out energy in twin columns that blasted through the galactic plane and carved the Fermi bubbles into existence. If that's true, then these glowing lobes are fossils of a violent outburst, long cooled but still echoing in light. They would mark the last time our black hole truly stirred, a kind of galactic exhalation that reshaped space for tens of thousands of light-years in every direction, a pulse of activity that, even now, continues to glow with the fading remnants of its fury. Another theory focuses not on the black hole, but on the galaxy itself. The Milky Way is a place of star formation and supernovae, especially near its center. Over time, these explosions can generate powerful winds, cosmic gusts that blow gas and dust away from the crowded core. These winds, driven by the death of massive stars, could have accumulated into a galactic outflow, slowly building up energy and eventually bursting into space in two huge expanding bubbles. If so, the Fermi bubbles are not just relics of a single event, but the result of a long, collective effort, a kind of stellar breath, rising and falling over eons. Regardless of their origin, the Fermi bubbles reveal something crucial. Our galaxy has a past written in more than stars. It has a history of power and eruption, of cycles that stretch far beyond human timelines. From Earth, the Milky Way appears calm, a soft band of light tracing the sky. But that calm is surface level. Beneath it lies turbulence. Beneath it lies memory. Scientists continue to study the bubbles in detail. They're not made of solid material, but of high-energy electrons spiraling through magnetic fields, releasing gamma rays as they go. Within their faint glow are hints of structure, filaments and ripples, eddies of plasma that speak to their evolution. Some parts appear brighter than others, suggesting complex interactions with the surrounding halo. And in recent years, other wavelengths, like X-rays and microwaves, have revealed additional layers, suggesting the bubbles are part of a larger, more intricate system of outflows and feedback loops within the galaxy. It's as if the Milky Way breathes in slow motion. It takes in gas, forms stars, explodes, and exhales. And every so often, something extraordinary is released, something like the Fermi bubbles. They also raise questions about timing. If the bubbles were formed by a flare from the central black hole, when did that happen? Some estimates place it as recently as a few million years ago, around the same time early hominins began walking upright on Earth. Others argue for a more ancient origin, perhaps tied to one of the galaxy's past mergers or internal reorganizations. Either way, the energy they contain is staggering, equivalent to millions of supernovae, all funneled into two focused beams. And they're not unique. Similar bubbles have been detected in other galaxies, hinting that this kind of structure may be common in spiral galaxies with active or formerly active centers. If that's true, then the Fermi bubbles are not an anomaly. They're part of a broader pattern, a hidden language of galactic respiration, visible only in the highest energy frequencies of light. From Earth, we live beneath one of these structures. It hangs above the northern sky, invisible but immense, a glowing echo of the galaxy's past. Its counterpart stretches below us, under the plane of the disk, like the reflection of a fire we never saw. And between them lies everything we know: our solar system, our stories, our civilizations. The Fermi bubbles remind us that we're not just part of a galaxy, we're part of its memory. We drift in the quiet aftermath of something ancient and enormous. We live in the lull between breaths, and somewhere above us, a ghost of fire still hangs in the dark, tracing the shape of a moment the galaxy can't forget. When a star dies, it does not simply vanish. It does not slip quietly from the stage or fade gently into silence. It explodes. It erupts in a final act of brilliance so powerful that it can outshine an entire galaxy. And in that cataclysmic death, it gives something back. Because when a star dies, it doesn't just end. It begins again, in pieces. The universe is not wasteful. Its beauty lies not only in what it creates, but in what it reclaims. Every atom in your body was built from elements that were forged in the heart of a star. Not just your oxygen, not just your carbon, but your calcium, your iron, your phosphorus. All of it had to come from a place hot and dense enough to fuse simpler atoms into something heavier. That place is the core of a star. And those elements don't escape gently. They're flung outward in a moment of staggering violence. A supernova is a death cry, but it is also a seed. When massive stars reach the end of their lives, they collapse under their own gravity, and in doing so, they ignite one last reaction, a burst so energetic that it sends the star's outer layers hurtling into space at millions of kilometers per hour. The remnants form a glowing shell of gas and dust, a nebula, suspended like a ghost in the dark. Over time, those remnants drift and cool, carried on galactic winds, mixing with other clouds of gas, until they begin to condense again. That dust, those fragments of stellar death, becomes the raw material for something new. It forms stars, it forms planets, it forms life. Every rocky planet, every moon, every speck of soil or strand of DNA owes its existence to this cycle of destruction and renewal. When you stand barefoot on the ground, you are standing on the bones of stars. When you breathe, you are inhaling molecules that were once trapped inside suns. You are not merely in the universe, you are made of it. This process, this recycling of stardust, has been going on for billions of years. Our galaxy is a machine of continuous birth and death, a system where matter is never wasted, only transformed. Stars form in nebulae, cold clouds of gas and dust that collapse under their own weight, sparking fusion when the conditions are right. For millions or billions of years, they shine, converting hydrogen into helium and eventually into heavier elements. Then, depending on their mass, they either drift away as white dwarfs or explode in one last act of creation. In those final moments, they shape the future. Even the color of a sunset, the rust on a piece of iron, the hemoglobin in your blood, none of these would exist without the generations of stars that came before. Our sun is a second or third generation star, meaning it was born from the remnants of stars that lived and died before it. Without those ancient explosions, our solar system would never have had the ingredients to form solid worlds or living things. The Earth itself is a kind of cosmic compost, built from the ashes of long-dead stars, and we are part of that cycle. The atoms that make up our bodies are not bound to us forever. They were borrowed. Someday, they will return to the galaxy, perhaps in a puff of breath, perhaps in ash, perhaps long from now, as the Earth itself is scattered into the void. But those atoms will not be lost. They will drift, find new homes, fall into new suns, and from those suns, new planets may form, perhaps with oceans, perhaps with eyes that look up and wonder. In this way, death is never an end. It is a handoff. A kind of quiet continuity runs through the galaxy, unbroken by explosions or collapse. Every ending is an offering. Even now, as you sit and listen, There are stars dying in far-off parts of the Milky Way, their deaths lighting up the void with quiet brilliance. You will never see most of them, but their debris will travel. It will scatter, and one day, far from here, it will gather again into something new. In a galaxy like ours, nothing is ever truly still. Nothing is ever wasted. The stars that came before us built the tools of life. And the stars that will come after us may one day find themselves building life again from the dust we leave behind. There is no grand ceremony, no celestial witness, no cosmic announcement when it happens. Just quiet change, just transformation in the dark. The next time you feel small beneath the stars, remember this: you are not beneath them, you are of them. The light you see is ancient, but so are you. You are made of the same things. You are not looking out at something separate. You are looking into a mirror, one scattered across a sky of fire and time. And in that reflection is the promise of return. When we used to look up at the stars, we imagined them alone, solitary lanterns suspended in space, burning quietly with no one to witness their light. For centuries, the only planets we knew were the ones in our own solar system, orbiting our familiar sun like children circling a fire. The idea that other stars might have their own planets was more poetry than science, a romantic guess suspended without evidence. But now, we know better. Now we understand that planets are not rare. They are not special exceptions. They are inevitable. When a star is born, it begins not in isolation, but in a swirl, a dense cloud of gas and dust collapsing under gravity, spinning faster as it shrinks, flattening into a disk. At the center, the pressure grows so intense that nuclear fusion ignites, and a star is born. But that star is only part of the story. The rest of the material in the disk doesn't vanish. It stays in orbit, clumping together, colliding, sticking, growing slowly at first, then faster. As grains become rocks, rocks become boulders, and boulders become worlds. Planets are not extras. They are leftovers, the inevitable byproduct of star formation. It happens everywhere. In the past few decades, with new tools and new patience, astronomers have begun to find planets around other stars. At first, they seemed strange, giant worlds orbiting scorchingly close to their stars, far different from anything in our own system. But as the catalog grew, patterns emerged. Planets were not rare. They were common. So common, in fact, that today we believe most stars in the galaxy have at least one planet, and many have several. The Milky Way alone likely holds hundreds of billions of planets. We call them exoplanets, planets that orbit stars beyond our sun, and we find them in clever, indirect ways. Some are discovered by watching the light of a star dim ever so slightly as a planet passes in front of it, a tiny eclipse that happens like clockwork. Others are detected by the star's wobble, a gentle tug caused by the gravitational pull of an orbiting world. Still more are found through gravitational microlensing, when the gravity of a star and its planet momentarily magnifies the light from something even farther away. Each discovery adds a piece to the puzzle, and with enough pieces, the galaxy begins to take shape. What we've found is staggering. There are lava worlds with molten surfaces so hot they rain rock. There are gas giants bigger than Jupiter that orbit their stars in just days. There are planets with multiple suns that rise and set in strange overlapping rhythms. Some worlds are frozen, locked in eternal night. Others are tidally stretched, deformed by gravity into teardrop shapes. There are ocean planets with no land, desert planets with no water, and even planets that may float alone in the dark, untethered to any star. And among them, somewhere there may be planets like Earth. We haven't found a perfect twin yet, but we've come close. Small, rocky planets in the habitable zones of their stars, where temperatures might allow for liquid water. Some orbit red dwarfs, smaller, cooler stars that live for trillions of years. Others circle stars like our sun. These planets are too far to visit, but not too far to imagine. Their atmospheres can be studied, their temperatures estimated. And with each one we find, the silence of the cosmos feels a little less lonely. The diversity of these planetary systems tells a story about the Milky Way. Our galaxy is not uniform. It is not simple. It is a canvas of endless variation, shaped by time, gravity, and chance. Some systems form with planets in neat, circular orbits. Others are chaotic, tilted, unstable. Some form with massive planets close to their stars, sculpting the orbits of everything else. Others allow smaller planets to drift outward, gathering ice and gas along the way. There is no single recipe. There is only possibility. Even the way planets form can vary. In some places, the disks around young stars are thick and heavy, rich in the raw materials of worlds. In others, they are thin and short-lived, giving rise to only a few scattered objects. Some systems may build planets quickly, within a few million years. Others take longer, shaped by collisions and migrations. And through it all, stars continue to form, disks continue to spin, and new planets continue to emerge. Our own solar system is just one example. It's tempting to think of it as typical, but it may not be. The arrangement of rocky inner planets and gas giants beyond may be unusual, or it may be one of many variations. We don't yet know. What we do know is that the architecture of planetary systems is wildly diverse, and that diversity is beautiful. It means the galaxy is not a repetition, but a symphony. Right now, thousands of exoplanets have been confirmed, and thousands more are waiting in the data. Missions like Kepler and TESS have changed the way we see the sky. Future telescopes will go even further, searching for biosignatures in alien atmospheres, capturing direct images of planets light years away. It is no longer a question of if there are other worlds. It is a question of how many, how strange, how varied, and how familiar. Because in the end, planetary systems are not rare jewels in seed, the galaxy's crown. They are part of its structure. Just as stars form in patterns, so do the planets that orbit them. Just as we orbit the sun, countless others orbit countless others. We are not the exception. We are the result of a cosmic process that has been playing out for billions of years, and we are only just beginning to see the whole picture. Far above and below the swirling plain of the Milky Way, where the stars grow sparse and the dust thins to nothing, there float strange and ancient structures, globular clusters, glowing like forgotten lanterns on the outskirts of our galactic realm. They are not part of the spiral arms, nor do they belong to the bustling disk of stars and planets where we reside. Instead, they orbit in the halo, detached from the daily chaos of stellar birth and death, suspended in the quiet borderlands of the galaxy. Each one is a sphere of stars, not a loose scattering, but a tightly packed, gravitationally bound swarm. Hundreds of thousands of suns crammed into a space only a few dozen light years across. They are some of the oldest structures in the Milky Way, and they've been drifting around its edges for nearly as long as the galaxy has existed. Some predate the spiral arms. Some may predate the Milky Way itself. They are stellar city-states, self-contained, ancient, and astonishingly stable. In the night sky, a few can be glimpsed through modest telescopes, like M13 in Hercules or Omega Centauri in the southern hemisphere. But through the eyes of larger observatories, their true nature comes into focus. A core so dense that stars appear to touch, radiating outward into a halo of shimmering points, each star an ember glowing in the cold. These clusters do not burn like the disk, where stars flare up and explode and new ones are born. Globular clusters are quieter. Their stars are old, metal-poor, and steady, mostly low-mass suns that have endured for billions of years. In their age is their power. Unlike the galaxy's inner regions, which churn and shift with time, globular clusters are remarkably stable. Their orbits are elongated and slow, arcing high above and below the galactic plane like celestial comets. Some take hundreds of millions of years to complete a single orbit. And yet, throughout all that time, while the Milky Way has twisted and merged and reshaped itself, the clusters have remained, their cores unbroken, their stars still humming softly in the dark. Their stability is mysterious. With so many stars packed so tightly, you might expect chaos, stellar collisions, gravitational disruptions. And yet, these clusters remain intact. Over time, interactions do happen. Stars can be flung out or pulled toward the center, but the whole survives. Like a beehive, constantly shifting within but always maintaining its shape. Some clusters even contain intermediate mass black holes at their cores, which may help stabilize their structure, like silent anchors in a sea of light. But perhaps the most profound thing about globular clusters is what they remember. Because they are so old, their stars hold clues about the early galaxy. Their compositions reveal what the universe was like when the first stars formed, what elements were present, what the galactic environment was made of. Many clusters contain stars nearly as old as the universe itself, fossils of a time before the Milky Way had fully assembled. Studying them is like finding libraries buried in orbit, each star a page in a book written 13 billion years ago. And not all globular clusters were born here. Some show evidence of having come from smaller galaxies that were later consumed by the Milky Way. Their motions, their compositions, their unusual alignments all suggest a life that began elsewhere, under a different sky. They are survivors of cosmic cannibalism, drifting remnants of galaxies that no longer exist, their cores preserved as stellar embassies in the halo of our own. In that sense, globular clusters are both native and foreign, part of the Milky Way, but also older than its current shape. They are not the builders of galaxies, but the remnants of its earliest architecture foundations that outlasted the walls, and they are still being studied. With new telescopes, we've begun to resolve individual stars in clusters once too distant to examine closely. We've mapped their internal movements, their chemical fingerprints, their oddities and outliers. Some clusters harbor stars with unexpected compositions, multiple generations perhaps, formed from recycled gas within the cluster itself. Others show strange dynamics, suggesting past interactions or hidden gravitational influences. But what draws us back to them, again and again, is their quiet endurance. In a universe where so much changes, where galaxies collide, stars explode, and planets melt, globular clusters persist. They orbit patiently through the dark, witnesses to every chapter of galactic history. They have seen stars rise and fall, structures form and dissolve, and through it all, they have held their shape. They are not centers of creation. They are not homes to life as we know it. But they are, in a way, the memory of the galaxy, silent, ancient, and watching. They remind us that not everything is chaos, that some things can last. And perhaps, far in the future, when the spiral arms have unraveled and the stars have faded, the clusters will still be there, drifting on the outskirts of a quiet, dark galaxy, glowing faintly with the last light of the beginning. The galaxy is not just stars and gas and dust. It is not only what we can see, those spiraling arms glittering with light, or the dark lanes of shadow woven between them. Beyond the visible, beyond the maps we draw with telescopes and wavelengths, there is another structure, one we cannot touch or photograph, but one that touches and shapes everything. The Milky Way has a magnetic skeleton, an invisible framework threaded through the stars like muscle through bone. It stretches across the galaxy, vast and subtle, guiding particles, bending light, and holding quiet power over the cosmos. Magnetic fields are not easy to notice. They don't glow or radiate in the way stars do. They cannot be picked up by ordinary cameras or even most scientific instruments. And yet, they're everywhere. The Earth has one, cocooning us in a protective shield that deflects solar wind. The Sun has one, shaping its surface and twisting into loops that flare with bursts of radiation. But But the Milky Way's magnetic field is something altogether more immense. It stretches for hundreds of thousands of light years, from the galactic center to the edge of the halo, threading its way through the spiral arms and the thick molecular clouds where stars are born. It is weak by human standards, billions of times weaker than a refrigerator magnet, but it is persistent, ancient, and pervasive. And in the scale of interstellar space, it matters. This magnetic field guides charged particles as they move through the galaxy. It sculpts the shape of cosmic rays, those high-energy travelers that zip through the void at nearly the speed of light. It nudges the gas and dust, influences the structure of nebulae, and even plays a role in how stars form from collapsing clouds. It is the unseen architecture that threads through the Milky Way's bones. How we discovered this hidden structure is a story of persistence and ingenuity. Astronomers noticed that light from distant stars was polarized, slightly aligned in one direction, suggesting that it had passed through dust grains that were themselves aligned by magnetic forces. Later, they mapped the Faraday rotation of radio waves, watching as signals from pulsars twisted slightly as they traveled through magnetized plasma. Piece by piece, they began to trace the shape of the field, like archaeologists brushing away layers of dust to reveal a forgotten skeleton beneath. What they found was a structure both ordered and chaotic. In some regions, the magnetic field flows smoothly along the spiral arms, following the pattern of the galaxy's rotation. In others, it loops and twists, shaped by turbulence and the motion of charged particles. Near the galactic center, the field grows more tangled and intense, as if drawn tight by gravity and the restless activity of stars and black holes. Farther out, in the halo, the field becomes more diffuse, like a whisper fading into the void. But it is not passive. This field exerts force. It shapes the paths of ions and electrons. It helps support gas clouds against collapse, delaying or encouraging the birth of stars. In some cases, it even sculpts entire structures, giant pillars of dust and gas stretched out along field lines, glowing in infrared or radio waves. We've seen this in star-forming regions, where young stars are being born inside clouds, molded not only by gravity, but by magnetism as well. It is a quiet sculptor, invisible but not absent. Even the light we see is shaped by this hidden framework. As photons pass through magnetized regions, their paths can shift slightly. Their polarization can change. The field acts like a lens, subtly altering our view of the galaxy and the universe beyond. Understanding it is essential if we want to read the sky correctly, to see not only what is out there, but how that light has been shaped by its journey. And still, the field holds mysteries. We do not fully understand how it formed. Was it seeded in the earliest moments of the galaxy's birth? Did it grow over time, amplified by rotation and turbulence? Does it drift or evolve, or is it anchored to some deeper structure we cannot yet see? These questions remain because magnetism is hard to trace and harder still to simulate. It slips through models and hides behind data, revealing itself only in fragments. Yet what we do know is this: the galaxy is not held together by gravity alone. It is threaded with force lines that stretch across light years, guiding motion, resisting change, shaping the flows of matter and energy. It is not a flat map. It is a web, a living dynamic structure built not just from stars, but from fields that hum through the darkness with a frequency we are only beginning to understand. We often speak of galaxies as islands of light in the cosmic sea, but perhaps it is more accurate to think of them as floating cities, held up not only by mass, but by invisible scaffolding. The stars are not just drifting, they are swimming through a medium shaped by magnetism. Every pulse of a pulsar, every whisper of interstellar dust, every burst of radiation carries the imprint of that field. It is the background structure on which the galaxy is built, as fundamental in its own way as time or space. We will never see it with our eyes, but it is there, passing through us even now, wrapping around the sun, coiling through the spiral arm where Earth orbits, reaching out into the cold between stars, into the great magnetic hush of the halo. The galaxy is not just a place of brightness and motion, it is also a place of tension, of connection, of invisible force. And in that force lies a deeper harmony, one that binds stars to stars, clouds to clouds, and shapes to silence. The Milky Way sings with light, but it is strung with strings we cannot see, and those strings are always, always humming. The Milky Way may look timeless in the night sky, pinned in place like an old painting brushed across the dark. From our quiet vantage point on Earth, it appears unchanged, a pale ribbon of stars stretching overhead just as it did for our ancestors and their ancestors before them. But this stillness is an illusion. The Milky Way is not static. It is alive in a way that galaxies are alive, growing, shifting, and breathing on scales of time far too vast for a human life to grasp. It inhales the raw material of future stars, exhales the remains of the ones that came before, and pulses in slow, cosmic rhythms that span millions of years. Galaxies are not closed systems. They are porous, open to the universe around them. The Milky Way is surrounded by vast clouds of gas, tenuous, sprawling envelopes of hydrogen drifting through the galactic halo. Some of this gas is left over from the galaxy's formation. Some comes from smaller galaxies it has absorbed. Some is recycled, flung out from the disk, and drawn back again in a slow loop of motion known as the galactic fountain. Like breath, this fountain rises and falls. When stars are born in clusters, they burn hot and fast. Their light pushes outward, and when they die, especially in supernova explosions, they send shock waves through the surrounding space, stirring up the interstellar medium. These events can drive matter out of the galactic disk entirely, ejecting clouds of gas into the halo. But gravity has a long reach. Over time, much of that gas cools, slows, and begins to fall back toward the disk. Not all of it returns to the place it left. Some flows into different regions, stirring the pot, enriching the gas clouds with heavy elements forged in stellar cores. This process is not just a curiosity. It is essential to the life of a galaxy. Without it, the Milky Way would run out of fuel. Star formation would dwindle and stop. But thanks to these cycles, the galaxy continues to feed itself, recycling material, mixing it, renewing it. And just as some gas returns, new gas also arrives. Cosmic filaments, the vast, thread-like structures that stretch between galaxies, carry rivers of intergalactic gas. Slowly, over billions of years, the Milky Way drinks from these invisible streams. The galaxy grows not in leaps, but in slow, persistent sips. It is not just matter that flows. The galaxy changes in shape and composition. Spiral arms twist and shift, not fixed, like spokes but drifting patterns in the stellar sea. The bar at the galactic center slowly rotates, pulling stars and gas into new alignments. Even the rate of star formation ebbs and flows, with bursts of activity followed by quieter times. These fluctuations are its heartbeat, and though it may seem like the galaxy is complete, fully formed, majestic and stable, it is still assembling itself. Over the past few billion years, the Milky Way has absorbed smaller galaxies, tearing them apart and mixing their stars into the halo. Some of those stars now orbit in strange patterns, clues to ancient collisions. Some still retain the chemical fingerprint of the galaxies they came from. The Sagittarius dwarf galaxy is one such victim. Its stars now stretched across the sky in tidal streams that wrap around us like faint galactic scars. As these mergers continue, the Milky Way becomes more massive, more diverse, and more complex. Its shape changes, its contents evolve. This is not a galaxy that has finished becoming. It is still in motion, still in the middle of its story. Even our solar system, nestled in a quiet arm far from the galactic core, is caught in these flows. The sun orbits the center once every 230 million years, rising and falling gently above and below the galactic plane in a motion that some have likened to bobbing on a wave. We are passengers on a vessel that is both stable and in flux, sailing through space with a destination that is always changing. And this process won't stop. Billions of years from now, the Milky Way will merge with the Andromeda Galaxy. That, too, is a form of growth, two vast systems becoming one. Their stars will not collide, but their shapes will distort and fold. Their gas will crash together, and new stars will ignite from the aftermath. The result will be something new, a galaxy shaped not just by internal rhythms, but by the push and pull of neighbors, by gravity's slow dance across intergalactic space. Even now, telescopes like Gaia and Hubble are helping us glimpse the motions behind the illusion of stillness. We can watch stars drifting. We can see the arcs of gas rising into the halo and falling back again. We can measure the slow, deep breath of the Milky Way. It reminds us that the galaxy is not a thing, but a process, a becoming. It is a city still under construction, a song still being written, a fire still burning. When you look up and see that quiet trail of stars overhead, remember, you are not looking at something frozen in time. You are witnessing motion made slow by distance. You are seeing the glow of a system in constant transformation. It breathes in matter, breathes out energy, and grows bit by bit, star by star, year by ancient year. The Milky Way is not done, and neither are we. The stars you see when you look up at the night sky are only a sliver of what truly surrounds you. The Milky Way's glowing arms, its clusters, clouds, and central bulge, everything, visible with telescopes and maps, is just the surface of something much deeper, more mysterious, and far stranger. What truly holds our galaxy together, what gives it structure and coherence, is not the matter we see, but the matter we can't. It's not in the brilliant stream of the galactic disk or the dense clusters shining in the halo. It is in the invisible architecture that wraps around all of it, silent and immense, a ghostly scaffold extending far beyond the stars. This is the dark matter halo. Though it has never been directly seen, this halo is believed to be the most massive part of our galaxy, outweighing all the stars, planets, and gas combined. It doesn't shine. It doesn't absorb or reflect light. It doesn't interact with electromagnetic forces, and yet it exerts gravity, immense gravity, enough to hold the Milky Way together when, by all visible measures, it should have flown apart long ago. Without dark matter, the way stars orbit the galactic center doesn't make sense. The outer regions spin far too fast. According to classical physics, they should be flung into space like sparks from a wheel. But they aren't. They keep circling, steady and serene. And the only explanation that fits is that something else, something invisible, is holding them in place. A sphere of unseen mass enveloping the galaxy like a cocoon. And this sphere, this dark matter halo, may stretch out hundreds of thousands of light years in every direction, dwarfing the luminous disk and extending far beyond what we can photograph or chart. It is the galaxy's true body, hidden beneath the visible skin. What is it made of? That is still a mystery. Candidates range from exotic particles like WIMPs, weakly interacting massive particles, to axions and sterile neutrinos, particles that may be relics of the early universe. But no one has caught one. No one has seen a dark matter particle collide or decay or leave behind a signature. We only know it's there because of how it shapes what we can see. It bends the light of distant galaxies, warps space-time in gravitational lensing arcs, and tugs on stars like a hand guiding them from the shadows. And it's not just a passive shell. The dark matter halo influences how galaxies form and evolve. In the early universe, it was the scaffolding around which normal matter gathered. Before stars ignited and before galaxies coalesced, Dark matter had already clumped together under gravity, forming halos that acted like wells in the fabric of space. Hydrogen and helium, the first elements, fell into these wells and began to gather, cooling and compressing until fusion sparked, and the first stars were born. Without dark matter, the universe might never have formed large-scale structures at all. There would be no galaxies, no clusters, no cosmic web. Just a thin, even fog of particles drifting forever. Even now, the halo shapes how the Milky Way moves and grows. It buffers the galaxy against gravitational disturbances, provides the weight that keeps the outer disk bound, and plays a role in interactions with smaller satellite galaxies. Some of those satellites, like the Magellanic Clouds, are themselves embedded in smaller dark matter halos. When they pass close to the Milky Way, their dark matter interacts not through collision, but through gravity, blending and merging invisibly. We don't know the full shape of the halo. We don't know if it's perfectly spherical, flattened like a pancake, or stretched into some other form by the galaxy's motion and past collisions. We don't know if it's smooth or clumpy, static or swirling. What we do know is that we are swimming inside it, right now. Every planet, every person, every drifting spacecraft is immersed in this unseen sea, carried along like leaves in a silent wind. It's humbling to think that most of our galaxy's mass is hidden, that we are only beginning to perceive the outlines of something that has always been there. For centuries, astronomy was a science of light, of studying what we could see. Now, more and more, it is a science of the unseen. We read the motions of stars the way archaeologists read the tilt of a broken pillar or the pattern of cracked stone. We infer the presence of something vast and ancient, not by looking at it directly, but by watching how everything else bends in its wake. It invites a kind of wonder, unlike anything else in astronomy. Not the bright, celebratory wonder of seeing a nebula bloom in color, but the quiet, unsettling awe of knowing that the universe is not what it seems, that the stars are not the whole story, that even the galaxy, enormous as it is held in place by something deeper, darker, and far more mysterious than we can yet explain. We live in a galaxy of ghosts, not ghosts of the past, but ghosts of the unknown, ghosts that shape the dance of stars, cradle the formation of galaxies, and whisper to us from behind the blows. The curtain of light. We are only just learning how to listen. When you trace your hand across your skin, you're not just touching the surface of a body. You're tracing the remnants of stars. The carbon that binds your cells, the calcium that gives your bones structure, the iron that moves through your blood, all of it was forged in the hearts of stars that lived and died long before the Earth was born. Some of those stars exploded in brilliant supernovae, scattering their enriched guts across space. Others ended quietly, their heavy elements exhaled into clouds of gas and dust that would, over time, become new stars, new planets, and eventually, you. You are not an observer of the Milky Way. You are made of it. It's easy to imagine ourselves as small and separate, floating on a minor world in an average star system on the outskirts of a typical galaxy. And in some ways, we are. But that image misses something deeper. It ignores the way the universe folds inward, the way time and matter converge inside a human body. You are not merely in the galaxy is in you. Every atom in your body has a story. Hydrogen, the simplest and oldest, was born in the first minutes after the Big Bang. But everything else, every trace of nitrogen, oxygen, sulfur, and phosphorus, was assembled later, in the extreme pressures and temperatures of stellar cores. These elements were pushed outward through time, passed along through stellar generations, until they found their way into a molecular cloud that collapsed to form our sun. The Earth was built from that same dust. So were the oceans, so was life. You are stardust, shaped by gravity and memory. The Milky Way itself is not just a swirl of gas and stars. It is a record, a living archive of all that has come before. Its stars move in patterns shaped by past collisions. Its halo holds streams of ancient galaxies it has absorbed. Its magnetic fields, its dark matter halo, its warped disk, all are shaped by a story of what the galaxy has endured and what it is still becoming. And within that story, you are a sentence, a whisper of thought passing through matter. Consciousness in a form the galaxy has only just begun to explore. You see, life is not separate from the universe. Life is the universe becoming aware of itself. Somewhere in the swirling of a spiral arm, a world cooled enough for chemistry to turn into biology. Molecules found ways to copy themselves. Cells emerged, then organisms, then minds. Billions of years passed, and those minds began to wonder. They built telescopes. They pointed them at the sky. They discovered that the stars above them were not gods or lanterns, but kin ancestors burning across time. They traced their own bodies back to the cosmos and found that the lines met over and over in the forge of stars. You are not outside this story, peering in. You are the galaxy remembering itself. When you close your eyes and imagine the spiral arms of the Milky Way, when you feel awe in the presence of distant light, when you wonder what else is out there, you are participating in something rare. You are a fragment of the galaxy that has learned to ask questions, to seek, to imagine. The Milky Way, for all its stars and gas and gravity, has only just begun to become aware that it exists. And it is doing so through you. Your thoughts are not floating above the physical world. They are rooted in it. Every neural signal in your brain, every flicker of memory and emotion, is a movement of particles shaped by laws forged in the heart of creation. Your ability to feel, to dream, to love it is chemistry, yes. But it is also starlight. It is the slow unfolding of complexity that began in the void and bloomed into life. There is nothing small about that. When you look up and see the galaxy stretch across the sky, you are not seeing something foreign. You are seeing home. A home with no clear walls, no borders. A home made of everything that ever was and everything still to come. A home that spins and collides, that breathes and changes, and that through you wonders if it is alone. And this is the quiet, beautiful paradox of it all. You are a fleeting arrangement of matter, a brief flare in a cosmic timeline that stretches billions of years. And yet, within that flare, something profound has happened. The galaxy has built eyes, and those eyes are looking back. You are the Milky Way, thinking. You are its question, its echo, its experiment. You are its memory made flesh.